So now we're going to define a few terms. So let's start with our first definition. We're going to say a process is random if, when it takes place, one outcome from a set of events is sure to occur, but it is impossible to predict with certainty which outcome that will be. So for example, if we flip two coins, we know that some outcome is going to happen for sure, but I cannot predict with certainty which outcome that will be. I don't know for sure what I'm going to get. There are a few other examples of a random process that you might want to think about, like choosing winners in a state lottery, selecting respondents in a public opinion, and one very important one is in medical trials, choosing subjects to receive treatments or serve as controls. That's also going to be a random process. All right. So the next definition we're going to look at is sample space. So the set of all possible outcomes of a random process is called a sample space. So we've already seen an example of this when we drew our diagrams for the two coins. That was listing out the sample space. And then within that, we're going to define an event is a subset of a sample space. So if we go back to our two coin example, an event could be that I get one heads out of my two coins. So now that we have these definitions, we can now talk about something called equally likely probability. So I'm going to write the statement here. So if we have S is a finite sample space, in which all outcomes are equally likely, and E is an event in S, then the probability of E is defined to be, I'm going to call it PE, P of E, and it's the following fraction, the number of outcomes in E divided by the number of total outcomes in S. So again, we saw this kind of thing earlier with our 2 coin example. When I wrote those 1 and 4, 2 and 4, we were using this formula right here to calculate the probabilities.